Today we're going to be talking about indices. Now, indices might be a little unfamiliar to you, but another way we refer to indices are exponents. So if you're not familiar with indices, if you think about it in terms of exponents, you'll be okay. Indices are just another way to refer to exponents. So if you remember, when you have a number a is multiplied by itself n times, it can be represented in the index notation of a to the n. Now, a to the n just means a times a times a times however many factors of n. And when we look, let's focus a little bit on the notation a to the n. A refers to the base, and n is the index of the base, or the exponent of the base. So we would read that as the nth power of a, or a to the power of n. So for example, if we have a to the third, that means we have 8 times 8 times 8, or 512. Similarly, if we have 3/5 to the fourth power, we have 3/5 times 3/5 times 3/5 times 3/5, which is 81,625/5. So what we're going to do is take a look at some of the laws of indices, dealing with positive indices right now. And we're going to take a look at some examples, and they're going to help lead us to certain laws that will help us throughout this unit. First thing I'm going to do is take a look at a couple of examples, and hopefully they will lead us to the answer here at the bottom to provide us with one of the rules for index notation. You can go ahead and work these out on your own. But if we take a look at the first one, we have 7 to the second times 7 to the third, which means 7 times 7 for 7 to the second, times 7 times 7 times 7, which is 7 to the third. So really we have 5 sevens being multiplied together. 5 sevens are being multiplied together. So then if I wanted to take 2 to the third times 2 to the fifth, that means I have 3 2's being multiplied by 5 2's. 4, 5, 6, 7, 8. And that gets me 2 to the power of 8. Then if we take a look at a to the fourth times a to the third, again, 1, 2, 3, 4 times 1, 2, 3, and that's a to the seventh. Now what we should notice here is some sort of pattern between the indices in the values in the bases that we're multiplying and the index in your final answer. And hopefully what we're noticing is that it really is just a value of adding the exponents together. So that when you have a to the m times a to the n, that just means whatever that value of index is, you're going to be multiplying it by that number times the number of the other indices of the other index, so that all you really have to do is add your indices together whenever you're multiplying the same base. Well, what about division? Is there another rule that's also useful for division? Let's take a look at the first example. I have 5 to the sixth divided by 5 to the second. So that means I have 6 5's being multiplied together divided by 2 5's. And so really, if you just look at it in terms of canceling out the 5's, you'll see that I'm left with 4 5's being multiplied together. 5 to the power of 4, or 5 to the fourth power. Same thing if I take 8 to the 7th divided by 8 to the 4th, I notice that they have the same base. And that's important. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4. So we'll notice I have 1, 2, 3, 4 8s being multiplied together. 1, 2, 3, 4. And what I'm left with is 8 to the 3rd. Now you might be asking, well, Mr. Chavez, what happens if you have more values in the denominator than you do in the numerator? We're going to get to that shortly. But for the time being, what you can start to see is that there's a pattern. Here where you notice you started out with a certain value, and you end up with a certain value. So for example, I'm guessing, and I'm not really guessing because I'm the teacher, that what will happen here is I have c to the 2nd. And then so if I'm left with b to the m divided by b to the 2nd, what it really means is what leads to our next rule, that when I have indices with similar bases, when dividing indices with similar bases, what you can do is simply subtract the exponents. So now it kind of looks like we have two rules regarding indices that might be useful to remember. And if we keep going, there are more rules even still. Let's take a look. Now I have a base and an exponent, or an index, raised to another index. So 9 to the 2nd to the 3rd, which means I have 3 9 to the 2nds being multiplied together, which also means each 9 to the 2nd is 9 times 9 times 9 times 9 times 9 times 9. So that ends up getting me 9 to the 6th. So I have 3 to the 5th to the 4th. That means I have 3 to the 5th times 3 to the 5th times 3 to the 5th times 3 to the 5th, which really means I have 3 times 3 times 3 times 3 times 3 times 3 times... You know what? I'm not going to say it all. You can figure it out from that point. So I have 23s that are multiplied together, which means I have 3 to the power of 20. And then what hopefully we're seeing here is a pattern that we can apply to generalize some sort of rule when we have a base raised to an index raised to another index, which really means we are doing something to those indices. And if you think about it logically, we've talked about the distributive property. We know that when something is outside of a parentheses, you would multiply it by that value inside. So that rule follows along too with exponents, indices. So we have a base raised to an index raised to another index. In this case, we have a to the m to the n, means we get a to the mn. Yet another rule involving exponents or indices. So the three main rules, just to recap what we've gone over so far. If you have a to the m times a to the n, that means you have two similar bases being multiplied by two similar bases with two different indexes or indices. What you can do is add the indices together and keep the base the same. Similarly, if you have two exponential values, what you can do, if the bases are the same, then what you can go ahead and do when dividing is subtract the indices together and maintain the same base. Then if you have a base raised to an index raised to another index, then what you're doing is simply multiplying those two values together. A to the mn, remember, just means m times n. So one thing that would definitely be helpful would be maybe to make a note card to write down the important values, or at least the important rules that you're talking about. And maybe some examples that help identify those rules. We'll be talking more about indices in the upcoming days.